Welcome back guys with a brand new video, and in this video we will discuss about the JK flip-flop. If you watched my previous videos relevant to the SR flip-flop and clocked SR flip-flop, then it will be easy for you to understand the JK flip-flop. If you didn't watch this, you can watch by watching the playlist of the flip-flops, or otherwise no problem, you can also understand by watching these videos. Basically, first of all, that's how we have to draw a JK flip-flop circuitry. After that, then we will discuss about the working principle of the JK flip-flop. Here we have the clogged SR flip-flop circuitry. But what's the difference between clogged SR flip-flop and this side of circuitry? The only difference is that was with two inputs. Now here we have, because of JK, it was with three inputs, each of the NAND gates in the first NAND gate. Then secondly, what will be going is here nothing. This is the similar, you can say, clogged SR flip-flops, but you have to keep one thing in mind, that your outputs of Q and Q slash will also become the input of the first NAND gate. Simply, this one is a previous, you can say, edge triggered D flip-flop also, but only the output of Q will becomes the inputs of K, and the output of output Q slash will becomes the input of J. Now what will happen? We will go towards the working principle of the JK flip-flops. Here you can see that if I load these inputs, then what's happening here? Nothing. One signal is coming as a clock and the other signal is always 1. That's why this output is always high or 1, you can say. Okay, now in the next step you can see the both outputs are high, that's why it's giving us low as an output. The both input are high, that's why it's giving a low as an input, and that's why this input is low, and this AND gate, due to this high output, it's giving us high at the its input high input, it's giving us the high output at this side, and due to these both high inputs, it's giving us a low output. Simply, this is, you have to understand the working principle of the NAND gate. Then you have to use the clock. This clock for the first circuitry is simply, and the second one is with the NOT gate. And if I load the L K also, then you can see here that there is no difference. If you can see here, okay. So if I make it again high, you can see this one basically is not affecting the K side for the output Q. Okay, only the J is, you have to keep this thing in mind, that only the J affecting the outputs, because we are taking the output as a Q. Now if I make this low, you will get Q slash at the output. If I make this high, you will get the high at the Q. But you can see here, when we change the J as a high, the Q will becomes high for a second and then again low, high and low, high and low. But if I make this low, you will see that we will get a constant high output at the Q slash. Okay, if I make this low and make this high, you will see that we will get a continuous high output at the Q. So basically, if we make the J as high, we will get, and K as low, we will get a continuous high output at the Q. And if we make the both high, then we will get, you can say, a flicker, or you can say always the output will be flip. That's why we call this circuitry as a flip-flop. And also This is the working principle of the JK flip-flop. I hope you understand and learn something from me. Thank you so much for watching the video. Please subscribe the channel and hit the bell icon.